There's something magical about the first light of dawn. In the moments before the sun crests over the horizon, the sky blazes with color, painting a breathtaking scene that humans have been awestruck by for thousands of years. As the sun climbs higher and higher, the vibrant hues soften and shift until the world is bathed in the warm glow of a new day. But what exactly is the sun? How does it produce the light that sustains life on Earth? And what secrets lie hidden within its fiery depths? Join us as we embark on a journey to uncover everything you could ever want to know about our nearest star, the life-giving ball of burning plasma that has fascinated humanity since the dawn of time. From its colossal size and age to the mind-boggling processes that occur within its core, we'll explore the fascinating science that powers our solar system and illuminates our world. So let's get started. The sun is a star, a giant ball of hot gas that shines by nuclear fusion. It's the center of our solar system and the reason why we have life on Earth. It makes light and heat that help plants grow and animals live. The sun is very big. It's about 1.3 million kilometers in diameter. That's big enough to fit 1.3 million Earths inside. It also weighs about 1.989 kilograms. That's a lot of mass. The sun is really old. It's about 4.5 billion years old. It formed from the leftovers of an ancient star that exploded. The sun will run out of fuel in about 5 billion years. When that happens, it will become a white dwarf. The sun is made mostly of hydrogen and helium. These elements make up 98% of the sun's mass. The sun's core is where all the action happens. It's the part of the sun where hydrogen turns into helium through nuclear fusion. This process releases a tremendous amount of energy, which is what powers the sun. The sun's core is about 14 million degrees Celsius. That's hot enough to melt anything. The sun's atmosphere is divided into several layers. The innermost layer is called the photosphere. It's the part of the sun that we can see from Earth. The photosphere is about 2,000 kilometers thick. The next layer is the chromosphere. It's a thin layer of gas that lies above the photosphere. The chromosphere is about 2,000 kilometers thick. The outermost layer of the sun's atmosphere is the corona. It's the part of the sun that we can see during a solar eclipse. The corona is much hotter than the photosphere, or the chromosphere. Temperatures in the corona can reach 1 million degrees Celsius. The sun rotates on its axis once every 27 days. It also rotates faster at the equator than at the poles. This is because the sun is not a solid object. It's a giant ball of gas. The sun's magnetic field is very important. It's what causes sunspots and solar flares. The sun's magnetic field is generated by the motion of electrically charged plasma in the sun's interior. Sunspots are regions of strong magnetic fields on the sun's surface. They appear darker than the surrounding photosphere. Solar flares are bright bursts of light that occur on the sun's surface. They happen when magnetic field lines on the sun get all twisted up and then release a surge of magnetic energy. The sun's energy reaches Earth in about 8 minutes after it leaves the sun. It travels through space in all directions. Some of the sun's energy is reflected back into space by clouds and other objects on Earth, but most of it is absorbed by the Earth's surface. This is what warms the Earth and makes it habitable. The sun is very important to life on Earth. Without the sun, our planet would be a frozen wasteland. So that was a quick overview of the sun. Now let's take a closer look at some of the amazing things that happen inside this giant ball of burning plasma. When the sun first formed, it was a big ball of hydrogen gas. Over billions of years, the sun has converted about 700 billion kilograms of hydrogen into helium through nuclear fusion. This process occurs in the sun's core, which is a region about 140,000 kilometers in diameter. The sun's core is so hot that it creates a plasma, a superheated state of matter in which electrons are stripped away from atoms. The plasma in the sun's core is mostly hydrogen and helium. The sun's core is also where nuclear fusion takes place. Fusion is the process of combining small atomic nuclei to form larger ones. In the sun, hydrogen nuclei fuse together to form helium. This process releases a tremendous amount of energy, which is what powers the sun. The energy produced in the sun's core is released in the form of gamma rays. Gamma rays are the most energetic form of electromagnetic radiation. They have very short wavelengths and high frequencies. Gamma rays are also highly penetrating, which means they can pass through most materials without being absorbed. This makes them dangerous to humans and other living things. However, the gamma rays produced in the sun's core don't stay that way for long. As they move outward from the core, they interact with the plasma and get absorbed and re-emitted. This process knocks electrons off of nearby atoms. The electrons then drop back down into their original energy levels, and the energy is released as X-rays. X-rays have longer wavelengths and lower frequencies than gamma rays, but they're still very energetic. As the X-rays move outward, they interact with the plasma again and get absorbed and re-emitted. This process knocks off more electrons from nearby atoms, and the energy is released as ultraviolet radiation. Ultraviolet radiation has even longer wavelengths and lower frequencies than X-rays. As the energy moves outward, it gets further degraded and eventually emerges as visible light. Visible light has the longest wavelengths and lowest frequencies of any of the electromagnetic radiation produced in the sun. It's what we can see with our eyes. The journey of a photon from the sun's core to its surface can take hundreds of thousands of years. The photons bounce around in the dense plasma, constantly being absorbed and re-emitted until they reach the surface of the sun. Once they reach the surface, they escape into space and travel to Earth. It takes about 8 minutes for the photons to reach our planet. When the photons hit the Earth's atmosphere, they're scattered in all directions. This is why the sky is blue. The blue color comes from the photons that are scattered in the atmosphere. The photons that aren't scattered reach the Earth's surface and provide us with light and heat. Astronomers use a variety of instruments to study the sun, including telescopes and satellites. Telescopes allow astronomers to see things on the sun in great detail. Satellites can orbit the sun and take measurements of its activity. One of the most important things that astronomers want to learn about the sun is how it produces its energy. To do this, they study the sun's activity, such as sunspots and solar flares. By understanding these activities, astronomers can learn more about the sun's magnetic field and how it generates energy. Astronomers also want to understand the sun's atmosphere. The atmosphere is the outer layer of the sun. It's much less dense than the sun's core, and it's where most of the sun's activity occurs. To study the sun's atmosphere, astronomers use a technique called helioseismology. Helioseismology is the study of vibrations on the sun's surface. The sun's surface is constantly vibrating because of the energy that's released in its core. These vibrations can be detected by looking at the sun's photosphere, which is the outermost layer of the sun's atmosphere. By studying these vibrations, astronomers can learn more about the sun's interior. They can also use helioseismology to map the sun's magnetic field. One of the biggest challenges facing astronomers today is that they can't actually see inside the sun. The sun's core is obscured by its outer layers, so astronomers can only observe the surface. This makes it difficult to study the sun's activity and atmosphere. But astronomers are using new technologies to get creative. They're developing new ways to observe the sun, such as using satellites to measure vibrations on the sun's surface. They're also using computer models to simulate the sun's activity. By combining observations with computer models, astronomers hope to get a better understanding of our nearest star. So that's it. That's everything you could want to know about the sun. This incredible ball of burning plasma has fascinated humanity for centuries, and for good reason. It's the source of our planet's energy, and the reason why life can thrive on Earth. As we continue to learn more about the sun, we'll undoubtedly uncover even more amazing facts and insights about this truly remarkable star. Thanks for watching.